Okay, I think we are good. Excellent. I'm just going to post this link to the Discord, assuming I can find it. All right, so I just need, there it is. Hello, a calico rabbit and Spike. It goes. It's gonna give it a minute for people to be able to hop on, but should have adjusted my camera before. I'm feeling pretty good so far about the trajectory of the jam. Well, thank you, Jacob. You're my hero. Authentic N64 game dev. Yes, this is for the N64. Although I am cheating and using an emulator for development because it's a lot easier to do that than it is to manage a console where you have to send the ROM over USB and reset. So why do I use GNOME? I haven't bothered to change the default that Ubuntu is installed with. I see some of the window managers people use, and I sometimes wonder if I should try them. I just haven't developed the willpower because what I use works fine for me. So, and what is my favorite cheese? Ooh, you know, lots of cheeses are good. It's hard to go wrong with cheddar, but yeah, I don't know. Too many good. I haven't used Sea Lion, or I have not. So I'm just use VS Code because that's what I'm used to. Although I feel like it's on a trajectory to becoming more bloated than it needs to be, and if it starts getting really slow and cumbersome, then I might find something else. All right, so I'm just gonna hop into it. If you do have questions, you can post them in the stream. I'm hoping to save enough time near the end to have dedicated to questions, but let's just hop into this. So first, let me zoom in on this. I always forget I should make it readable to the stream. So I wanted just to quickly go over, if you caught the last stream, some things that I was working on. So I mean, I made some progress. Let me just show what I have right now, and then we'll jump in to the code. So now you can, those are the buildings and the little character. I'm the character moving in the top left corner, and you can see I can collide with buildings. So I've done some work on the collision code already, and I wanted to mention something. So from the last stream, I ended up modifying the tiny 3D export script, and they actually recommend that you just stick with Blender 4.0. So let me just show you the the final process for making changes to models. So you notice I open up specifically, it's Blender 4.0. Don't go 4.1 or 2. And so here's that really janky character model that I have. Let's say I wanted to, I don't know, make this even pointier. And then I want to export this. So you come here to export. This is going to be small. I hope this is legible to you on stream. But if you come here to File Export, it's a built-in file type, GLTF. And so yeah, GLTF, it will scale things by 64, which is good because the vertices are stored in integers, so we need that. And then you expand the include over here, you select, you want to exclude, you want to export custom properties, and then you click export. And now if I were to make, you can see it rebuilt the T3D model there. And so now if I run it, you can see it's pointier now. I don't know if it's obvious on stream, but that's how you do the export process. And then one very important thing, be sure you have the FAST64 extension installed. If you just look up FAST64 online, I'll just pull up the website so you know what it looks like. This is a recap from last time, but I think there are some questions as to like how to do this still. So I just want to be sure. So this is the plugin you want. Follow the instructions on this page to install it. And when you come in, you want to, on the materials panel, you want, oh boy, is it not activated? Oh, it's not. Oh no, it is. Okay, so I just need to activate it. Okay, there we go. So now it's activated. And so you can see this player material, I created it using this Create Fast 3D Material button, which I don't know if you can read any of this text. I apologize if you can't. Yeah, 720p stream. Yeah. Hopefully, if you can see this area, I don't know how to zoom in the UI. I click on that. That's how I created this material, and you can just edit the material settings in here, and you'll see a live preview of what that's going to look like on the N64. So that is that. I just wanted to go over that again. I actually created a shortcut to that process. I actually added a make rule. I added it to the template, but I'm just not going to commit that. But I created, where is the rule? Where did that end up? Oh, I think I added it to mine. Okay, I added it to the Rampage make file. So any assets in the Rampage make folder that end in .blend, I actually wrote a rule in the make file that converts the blend file into a GLB file, so I don't need to go through that manual export process. If you want to copy that, feel free. You just pull up my repo, my version of the repo. So that's how I'm doing the models, but I want to focus on collision detection for this stream. So my collision detection methods, I just ripped my collision detection code from my current game project on N64. I simplified it just a little bit because there were features I didn't need, but that's just this collision folder. Again, if you want to just steal all of this code, you're welcome to. If you just pull up if you go to my GitHub, let me see. Come to my GitHub, Lambert James D, and you look up these. Look up right here, this template repo. This will be where I'm pushing my changes. You can yoink my collision code. I don't mind. It's not going to be very intuitive or documented, so just as a warning, if you would prefer to use something documented, you could try using like a 3D physics engine. I personally would be worried that it'd be a little bit too big for N64. Like they're made for modern physics problems. You could try it though. Maybe if you turn down the number of iterations and you use very simple shapes and simple meshes, it might still be performant. I don't know. I know somebody previously did use, I think it was bullet physics in an entry before, and it ran. The frame rate wasn't great, but it did run. If your gameplay can operate in 2 dimensions, I would recommend Box 2D or Chipmunk. Those are 2D physics engines, and even if the graphics look 3D, but the gameplay's 2D, that would work. But anyway, my physics engine, it does 3D collisions and 3D movements, but you can only rotate in one direction. And that simplification, I think it fits better to typically what N64 games want anyway, rather than full 3D, like rotating and tumbling like a 3D object. But it's much faster to do collision detection that way. Much faster and simpler. So I just went with that. So, all right. Anyway, moving on. So I just want to do a quick tour of how my collision library works. Again, don't feel like you have to use it. Really, if you just know, even if you can write your own simple collision routines, that's probably just fine. Don't think you have to have something very sophisticated. But with this one, you call collision scene init. That initializes all of the collision for, well, just initializes the collision and physics library. More collision than physics. and I'll get to that in a minute. And then collision scene use static collision. So this is what sets the global static collider. There's only one of these and it can't move. And right now I just have it hard-coded as a single mesh that is just a single flat rectangle. And it's not going to be very intuitive if you want to try to edit this and make a more complicated mesh by hand. If you did want to do that, I would recommend that you actually pull up my, one second, tabs. Somebody was just complaining that I was using GNOME, and here I am struggling with Windows. If I was i3, I wouldn't need to be dealing with Windows or something. I don't know. Anyway, Spellcraft here. So if you wanted to actually make there is an exporter for that mesh format inside of this repo, Spellcraft, and if you just it's located in Tools and Mesh Export. Which one was it? Well, maybe I don't know. Let's look up the make file. I think is it CMesh, collision mesh? I know. Okay, it's in assets. Oh, it's the world exporter. So that's going to be kind of tied up with other things. Okay, so forget that. I don't have an easy exporter for collision. Maybe I'll separate out the level exporter and just pull out the mesh export, the collision mesh exporter, and include it in my template. Maybe, or maybe I won't, and I'm just going to stick with this flat, simple mesh. But the dynamic things, the things that can move, those all get added later. And how I do that, so for the buildings, for example, I include, I'm calling it dynamic object, and I know my variable names are terrible. And I know somebody's probably going to complain that I don't use type defs for my structures in C, and I just don't. And I don't have an explanation, and it's probably better that I don't. It'd be probably better if I did type defs, but I just don't. And I don't mind. So there you go. And so you just have to include that as part of an object, and then you do dynamic object initialize. You want to give it a unique ID. That's how you identify objects that have been collided. So if two things collide and you want to have a response, you use the ID of the thing you collided with to determine what you hit. So that's just why everything needs a unique ID. A pointer to the object I want to initialize, the shape of the collider, I'll get to that in a second. And then collision layer tangible, that's just if you want things to be on different collision layers, so some things can pass through each other, you put them on different layers. I think I'm only going to have a single layer for this game jam, so that's not necessary, but it's there. And then you have to specify the initial position and the initial rotation, which my rotation is a two-dimensional vector, and I think this is the best way to represent a rotation. If it's basically a complex number, but of length 1, so a unit vector in 2 dimensions. And you can think of it as when you have to rotate objects, you do that using sine and cosine often. And so a 2-dimensional vector is just the pre-computed sine and cosine for the rotation. But representing your rotation in that way, I think it comes with a whole host of benefits. I feel like it deserves its own video. I'm probably not going to go too deep into it right now. But basically, the gist is if you ever have to use sine and cosine in your code when it's not interacting with humans, when it's just like you're trying to do computation for like collision or anyway, you typically can replace your sine and cosine in optical trigonometry with vector math, and it's going to be faster. It'll probably be fewer lines of code and have fewer buggy corner cases in my experience. So vectors are way better than trigonometry, in my opinion. So that's how I represent rotation. So g right 2, that's the right vector, meaning x is 1, y is 0. So if you look in the complex, let me just draw this. First stream, welcome, Dilthilium. First stream, yeah, I'm focusing on collision detection here, and I'm maybe spending more time than I should explaining this, but I really am passionate about vectors versus trigonometry. So like if you had like a plane, and this is the positive x, and this is positive y, then you can define a unit vector on this unit circle and pretend like that's consistently a circle around the origin. And so this point right here would be x1, y0, and that's no rotation. No MS Paint. I am on Linux, so there is no MS Paint. Although, if I could get it, I might be able to, who knows, maybe it runs on Wine, and I could actually yoink MS Paint. This is what I'm going with. So you can represent a rotation just by where this point is around the circle. And so if you want to rotate 90 degrees, you would specify your rotation as this point up here, and it rotates it that way. And so you can imagine just all along that you get complex numbers. And the cool thing is if you multiply two complex numbers together, it's effectively just adding the rotations together. Or if you want to find out if they're if two rotations are a certain angle apart, you do the dot product on those, on the two vectors, and that gives you the cosine of the angle. And so you could pre-compute the cosine of the angle as a threshold and just compare against that pre-computed threshold to determine if two vectors are facing relatively the right direction. And you don't have that problem you do with angles. So for example, if I want to represent this as angles, suppose I have this angle and this would be like what, like 10 degrees, and this would be like 350 degrees. So, and to say, okay, are they within 30 degrees of each other? Well, if you take and you subtract the two, that's not going to tell you that. But using dot products between these two vectors, it doesn't matter that they are crossing over the 0 point. It'll still, the math will still work out consistently. So you remove a lot of these corner cases by doing vector math over trigonometry. And if you get good at trigonometry, if you get good at vector math and learning the ways to do it, I feel like things just work out better and it's faster. And anyway, that's my little rant. So yeah, a little rant on that. So that's why this is a two-dimensional vector for rotation. So, and then I see, this is where my library, my interface sucks for my collision library. But the initialize just kind of sets up all of the essentials. But other features you have to set later. So for example, actually no, I'm thinking I'll move this variable to be part of the object collider type. But this variable specifies the collider relative to the position. So for example, my colliders, I should just keep my programs open because I have to keep reopening them. My character origin is defined at their feet, and I think that's pretty typical in game development, where you put the origin at the feet, so that way when you place an object or character in the world, like the point that they're placed is the location on the ground and they stand on that point. Well, that means the collider isn't centered around the origin of the object. Instead, it's centered by an offset. That's what this center offset is. So I'm just telling it to shift the collider up a little bit. Collision group. So collision group tells the game engine, do not try to collide two things in the same collision group. And so I put all the buildings in the same collision group as just an optimization, because they're never going to actually touch each other, and wasting cycles asking if they, doing the more detailed collision detection code is wasted cycles if I can just quickly tell it, hey, you're all in the same group, don't collide. And then the last thing after setting up the object is I tell it collision scene add, and at that point it's part of the collision scene, and the features you get, it will collide with other objects, they'll push on each other unless they're fixed. If they're fixed, they don't move. And gravity is applied as well, so it will give you gravity. Although right now the gravity is set to be 9.8, but I haven't scaled that by 64 because that Yeah, so the problem is gravity is actually quite a bit slower, or it feels very slow. Um, so I'll probably tweak that number later once I actually get to jumping, but I'm not going to worry about that right now because it's not an issue. And yeah, any thoughts or questions so far? Let me see. Let's just assume everything's a perfect frictionless sphere. Oh yes. Actually, I think I did turn friction. No, friction's on. Bounces off for this building anyway. Um, if you had a zero grav world, would you use would you use B true center? If you had zero grav world. Oh yeah. Yeah, that would make sense. Yeah. If things were floating around instead, and it might make sense, yeah. The center would make sense to be in the center of the object. I think that would be fine. Um, filtering web rocks before B silt. Oh, the B is the filtering with rocks. I see. Filtering with rocks before the. Use a menu editor to add Blender 4.0 to the app menu. Oh, yeah, I could do that. I I have multiple versions of Blender that I operate on though. Right now for the jam I'm using 4.0, but for my personal project I'm using 4.2. I don't know. I don't mind choosing the version every time I run it. Um, all right. Moving on. So I can add things to the scene, and so that's so the building is a pretty straightforward script here, or entity, I guess. It's really just I add the collider to the scene. Um, when the building gets cleaned up, I remove it, and then on render, I just apply identity rotation, which means there's no rotation of the building. Scale, I just do a fixed, no scaling, and then I just take the dynamic object's position and use that as the position when building the matrix, and I just draw the building model. The assets are loaded all batched here. Rather than having every building reload the asset, I just have the game load all of these global assets once, and then I reference those assets later. So that's what's going on there. So you can see the building's quite simple so far. We're going to be changing that here soon. And the player right now is simple as well, but a little more complicated. So it has a similar initialize at the start where we set up the dynamic object. It's not fixed, so it means it can move. I do also have that offset center. I added the collision seam. The player type just determines either what number player they are or if they're AI. And then I do set up this block here. This isn't really that necessary. The buildings don't do this, but a RSPQ block is a batch of commands that get generated once, and then later when you're rendering, I can just run that block. And so it's almost like calling a function, but for the GPU. And that function is generated ahead of time. So that is a really nice thing. If you have a really expensive block, you can do that. Right now, it's probably not worth it, what I'm doing, but eventually when these become 3D animated characters with armatures, it might make sense to use a block. That's why I have it as a placeholder. And then, yeah, the update logic here is going to be a little more complicated. So I have a function where I get the input for the player. This is also going to be where the AI gets implemented. So basically, this function just says, I just want to know what input this character wants to give, and the input direction gets turned into a velocity on the dynamic object, and then I look at the current velocity and I say, okay, if there is something of a velocity, I figure out what that normalized direction is, and I make that the current rotation. So this is how I rotate the object, and then down here, when I render, I turn the rotation into a two-dimensional rotation to a 3D rotation, and then I pass that in when constructing the matrix. So Discord is demanding my attention. I am going to exert. Maybe I should close it or mute so it's not distracting. There, it's gone now. So the so this is one of the examples where I just think doing things with vector math is so much better than trigonometry. So if you tried to do a rotation matrix before, you'll know that it involves sine and cosine. And if you're doing Euler angles, it's terrible. Like you have to do sine and cosine, so one sine, one cosine per matrix. But there's three rotation angles you have to do. So that is actually 6 sines and cosines. Maybe if some of those angles are 0, the functions can short circuit and give you a quick answer. But then you take those 3 matrices, you have to multiply those together, which is a lot of work to multiply those 3 just to get the rotation. And sine, cosine, they're expensive. They are quite a bit more expensive than square root, which is what this normalized. So by saying the direction that I'm going, I normalize that to a unit vector. And that unit vector now becomes my rotation. And that's just a square root and a divide. Divide, then because if my normalized implementation, you see I calculate the denominator once, and then if it's not 0, I do the division once, and then multiply that division, because divisions are really expensive on N64. So I only want to do one division, and then I multiply the inverse. So it's mathematically the same, but it's faster. So it gives me the rotation here, and then this implementation to convert from 2D to 3D, this is a function I wrote, and you can see it only has a few multiplies and a square root. And so you can see that is a lot faster than doing a rotation matrix using sine, cosine, and filling out a giant matrix. It uses less memory, so the RAM bus goes vroom vroom. It's just overall better to do rotations using unit vectors, which a quaternion is just a 4-dimensional unit vector which can be used to do 3-dimensional math or 3-dimensional rotations. It's weird. So that would you not use a lookup table for sine and cosine? You can, and if you have to do sine and cosine, I mean, I think K's has done an excellent job of optimizing sine and cosine. Like, I've been really impressed with kind of his investigation in that. Lookup tables, though, you have to be careful on N64 because it would be a cache miss pretty much every time, because you're very likely to be looking up a different angle most of the time anyway, and so it's a cache miss. And then you can't really do a lookup table for every single angle. I mean, if you limited your angles to maybe like a byte, you could. So like you'd have only 256 possible rotations, and you can do a lookup table, and you could do a direct lookup. But if you don't have a direct lookup, you can do interpolation. There's ways you can improve on that. But I figure I just sidestep the whole thing and just say I'm just going to use vectors, which I don't need trigonometry for, and it's going to be faster. There's a hardware instruction for square root. So anyway, that is my high horse about vector math versus trigonometry. So I wanted to go over a little bit about my collision code, though. So the way I define shapes, I briefly talked about this when I made a video about it for Portal 64. And I use, which is probably my favorite algorithm, GJK and EPA. Well, those are 2 algorithms, but they're really cool. And I guess I'm a pretty big nerd because I have a favorite algorithm, but it's pretty sweet. Because, so for example, here I've defined the box shape here with just these 2 functions and the data that gets passed in. So one of them calculates a bounding box, So that's just used to do fast discarding of collisions. So like I guess like to do collision detection quickly, what you want to do is you want to discard collisions that just don't have a chance of colliding as fast as possible, and so a really easy way to do it is you calculate a bounding box, axis aligned bounding box for every object in your scene, and then you can use that to first check bounding box to bounding box collision, which is really fast. If the bounding boxes don't overlap, then the shapes definitely won't overlap. So you can discard those much faster. It's only when the bounding boxes overlap that you need to move on to the next step, which is GJK, and it is awesome. So like the only thing you need to implement is called this. It's called a Minkowski sum. I'm gonna call it a support function. I think that's what I've heard it called before, and it's much easier to call it by that. And it's pretty rad. So it's a very, very simple interface. In fact, I can show you the interface. So come here. Come on, if I can control click on the right place. Computers are hard. All right. So this is the interface. I don't have a return type. The output is a pointer output here. But you can see, so the data is only there because C doesn't have classes or like data closures. Well, I guess it kind of does. I think I've seen it. But the point is, this is like the this parameter if you're thinking in the object-oriented terms. It's the data needed to perform the calculation. And then the actual input into the function is this direction vector, which is just, it is not necessarily a unit vector. So that's something that's important you to remember if you're implementing this. But it's just the direction that you want to ask on the shape, and the output is the point that exists on the shape that is furthest in that direction. That is the only thing you need in order to implement collision detection with GJK. And like, it's just so elegant. It's so simple. And so like adding new shape types is super easy. And the cool thing is you can actually do some things to compose shapes together. So, okay, if this came up. So for example, so suppose I have a triangle here and I want to implement the support function. So you can see if I had the direction was that, you can kind of see, okay, well, if I follow this direction, I hit this wall, but then I can keep sliding along it until I get to this point, and that's the result of that direction, right? Or if I picked, I don't know, like this direction, you can see, zoop, hits that, slides over here. This is the point it returns. So what if we wanted to say, okay, rather than knowing if I'm colliding with the triangle, I want to know if I am within 10 units of the triangle, right? Like, and you could do this. You could do this rule with any convex shape. Well, you could just modify the support function to say, okay, whatever value I hit as my result, and I have this direction, just move 10 more units in that direction, and that's my new point. And what that will do is it'll create like this boundary that becomes the new support function shape. And that support function defines the area, which is the space 10 units from the outside of the triangle. Or another thing which I use this in Portal 64, and I'm using in my current game. You can say, well, what if, I have this shape, and I have, okay, I need to do that one more time. There. All right, so I have this shape. This is where it started. This is where it ended up. And I want to define a shape that represents the entire volume, or I guess more than just volume, the entire, I'll just do volume. I guess in 2D it's area. The entire area where it swept through. Well, I just make the support function, so it just, the first step is to do the support function normally on the starting position of the triangle. The second step is, you can see this is the direction the triangle moved. This is the vector it moved in. And so I just say, okay, if the direction I'm querying in is on this side of this plane here, then I shift the result by the amount it moved by, so it becomes this point over here. So if this point becomes that point, this point becomes that point, anything along here becomes that point over here. But if it's not, I just keep it back over here. And that, just by modifying the support function, I can do swept collision. And the cool thing is that's generalizable to any convex shape. So I don't need to write a swept collider for all of the shapes that I want to support. I can implement the shapes separately, just like I do here. I have one for box. The few shapes I have one for sphere, I have box, I have capsule, I have a cylinder, and like it's really easy to add new shapes because I only need to implement these two functions, and I don't need to implement pairings between all of the shapes. You only need this one support function for the shape, and now you can collide with all other shapes. That's the cool part. If you ever tried to do collision libraries before where it's like, here's the code that collides, I could show you. Do I know what I know to search for off the top of my head? There's websites that have like these pages and pages of like, here's collision between box and box and sphere and box and cylinder and sphere, and like the combinations explode and the math is complicated for each one. And if you ever tried to implement collision that way, you'll know what I'm talking about, and it sucks. But when you use GJK with this support function, it's a linear relationship, not n squared. Every shape type you add just works with all existing shape types immediately. It's really cool. This is why it's one of my favorite algorithm. It's really cool. And then expanding on that, so I have all these shape types. I have capsule, I have box, I have sphere, and I'm able to write a routine that says, okay, I want to do whatever shape this is, but I want it to be a swept collision from this point to that point, and I can implement that once for all shapes, and it works for all shapes. Or you could the same thing with I want to know if I'm within 10 units. It just works, and it's really cool. So that is why I love this algorithm so much, and that's and maybe for this game jam it's a bit of an overkill because I only have like a box and a capsule shape. I actually might do a rotated box for a tank later, but you can see that's what I have here. So I've defined. So this is kind of messy part of my interface here is I have to define a dynamic object type as just static with a static initializer, which means it's kind of repetitive. I have to say I want the capsule type, the data. I'm using a union type here, so all potential collision types have to specify the data as a union in here. This is my kind of questionable way of doing polymorphism here. But anyway, I specify the capsule data, and then this is common to all shapes, so it just bounces in collision. So I can use this collider type when I initialize the dynamic object, and that's how I've implemented that. So anyway, I think this is about it when I wanted to stop moving on. I could talk about GJK for another 30 minutes, but I actually wanted to move on to actually implementing something here. So I think what I was going to do, I want to add I want to be able to damage things. So I am going to, I'm going to do exactly that. Let's double check that I don't have, okay, I had a print statement there and earlier. I want to make sure I cleaned up. So I'm actually going to do this by just adding another dynamic object, but this one is going to exist in front of the player at all times. So I'm going to do this one as the damage trigger. And this, I'm going to do a shape, probably a cylinder. So let me grab that. And by the way, my shapes are vaguely cylinder and vaguely sphere. They're actually kind of polygonal. And the reason why is curved surfaces take more iterations to converge with GJK and EPA. and maybe it might be premature optimization, but I decided to do more polygonal looking shapes, so it converges faster. But it also, it fits better. It has a better fit with N64 anyway, and I was able to implement those without using square root. Because normally, if you want to do a properly smooth sphere, I need to take the direction and normalize it, which requires a square root and a divide. Both are slow. But because the way I'm doing it with a kind of a polygonal looking sphere, I'm able to get away with implementation only using multiplies and adds, which is much faster. So I need dynamic object type, damage trigger, collider. All right. So the support function, I'm going to use the cylinder support function. The bounding box is going to be the cylinder bounding box, and then the data, I need to specify the cylinder type, and so I specify a radius, scale fixed point. So I've just been operating in the scaled unit, so multiply everything by 64. And so I want to think in terms of what my Blender units are, so that's why I have this going on. Yeah, 0.5 is fine radius. I'll figure out what actually feels better over the long run. And then half height, I'll just use the same height as the player for now. So because this is a capsule, the half height's actually these two added together. So this is actually going to be 1. All right. And then bounce and friction don't matter. I can actually just leave them off in the default to 0 because this is a trigger. So then I come back down here and I'm going to do a dynamic object initialize. I'm actually going to reuse the same entity ID, player. I'm just going to store this into Do you hear my son in the background? The yelling. All right. Entity ID. Yeah, if colliding. Yeah, so your spheres, icosahedron. Oh man, I'm saying that wrong. Or even more polys than that. Yeah, it's like I'm not actually defining it as a polygonal face. If you just looked at the support function, it might. I'll just show you really quick. So if I come here to the sphere support function, so it's okay. This part I don't have to worry about right now. So what I do is, if you imagine the 3 cardinal directions of a 3-dimensional XYZ, and then if I say what's the furthest, so if you just took the x and y positive, negative in all directions, like a unit sphere here, and just only worried about the points on the corners, you can imagine if you took the convex whole of that, it would be round-ish, but it's going to be a weird diamond-looking shape thing. Well, I do that, but then I also... Is that all I do? That might be all I do here. Okay, that's all I'm doing. I think I tried to add some sort of... And I also check some other direction, like I rotate it in a way that, and check some other thing, but I guess that's all I'm doing here. So the shape is pretty basic. It's like actually it would be kind of not quite a cube. It has 6 points on it. Anyway, so you can see so it's this is the support function for a sphere, and you can see I get away without any square roots. It's just kind of greater than, less than checks, some multiplies. In fact, do I even have a multiply in here? I don't think I do. So it's a very simple way to do a sphere. Anyway, the box one's accurate. If you want, in fact, maybe I show the box one as a good example of the support function. So you can see here for the support function, I just check if the direction x is greater than 0, then I return positive half size for the x direction. Otherwise, it's negative, and I do that with every axis. And so you can see this support function, it doesn't do a single multiply or add. It's literally just, it's super simple to do it for a box. So this is a pretty basic example of a support function for a box. And the bounding box is actually more complicated because I have to take into account the rotation, whereas the rotation is already taken into account from the caller of this function. So the caller worries about rotating the result from the support function, which again simplifies making these support functions. It's great. Anyway, let's just get this player. We're gonna do the damage trigger collider. I want to collide with anything tangible, and then the start position. I'll just pass in the start position, but I'm actually going to be I'm going to be calculating the collider position and moving it on the fly. And then, so we've done that. I want to, the damage trigger y is equal to, let's use that same thing. And then I actually want to, is trigger. I want to set that to true. So a trigger doesn't push things. Instead, it just collects all of the contacts of things that are touching it and reporting that. And then the last thing I actually wanted to do here, so the player index should be passed in here. So I'm the player init. I'm going to do player index so we know what index the player is, which means I'm going to have to come to my rampage.c here, and on the initialize minigame init, rampage init down here. I'm going to initialize the player. I also want to specify the player index. So that way, I need to do .center.y here. Okay. So now I know the index. I can have a player. I just had a thought. Right now I'm just randomly generating these entity IDs. Well, not randomly generating them. They're just being sequentially generated. But what I might do is pre-allocate all of the entity IDs, so that way it just knows. I could look up. I could say, if the entity ID is in this range of numbers, I know I'm hitting another player. I'm not going to worry about that right now, but I think I actually might do that from implementation. But I am going to say the player. Actually, you know what? Okay, no, I'm not going to do that. No, I am. I keep flip-flopping. Oh no, I'm not going to do that. Okay. I was thinking of just reusing the entity ID as the collider group, but I'm just going to first player collider group. So this is, the buildings have a value of 1, this collider group of 2, because what I want to do is put the player, both the dynamic object collision group, I want both the collider and the trigger to be in the same collision group, which would mean they don't collide with each other. So that way the player, when it does when it goes to see who have I damaged, it'll just ignore its own player collider. All right, so I've done that. I've marked it as a trigger, and I'm going to add this separately here into the collision scene. Okay, so that's been done. I also want to make sure I remove it on the cleanup. And then the next step, I need to update the position of it. So I'm just going to write a routine for that and then call that in both the update and the initialize. So I'm going to say rampage and say player update update damager. I don't know. And so I guess I'll do two things. I can check to see what things have been touched in the previous frame and update the position so it's in the right spot. So this is where I'm going to do fancy vector math here. And so I'm going to say the damage trigger dot position dot x. Let's see. I want to actually create an offset. And so the offset The X is going to be the rotation player dynamic object dot rotation dot z dot y, and then the y is going to be 0, and then the, I think this is right, I'll have to try it, rotation dot x. So I'm converting the rotation, I'm converting that to an offset from where the player's facing. I want to multiply this by the distance of the, like how far away the damage collider is going to be. I'll just define that here. Damage distance, sure. And then it needs to be the scaled fixed point value, I don't know, 0.75 away. And so this needs to be multiplied, so this gives me the offset, and then I can just do a vector 3 add now. Vector 3 add from the player dynamic object dot position to the player damage trigger position, and I am, oh, that's the output, and then I need to offset it by this much. All right, so that updates the position, and then the way I keep track of the collisions is the collider keeps a linked list of all of the contacts on it, and that gets reset every frame. So I should be able to just do a, I can't remember the type, I think it's just contact. I'll just contact, I'm just going to call it the current, and so I just say the dynamic trigger dot active contacts. Let me double check the type here. Oh, it's lowercase c contact, but yeah, contact. All right, and so I can just say while there is a contact, I go to the next one. And then for now, what I'm going to do is I'm going to just do an printf. So fprintf std error. So this, if you need to debug anything, this is what you want to do. And I'm just going to print the contact other object. And so that is the unique number. The right here I pass in the entity ID when I initialize the dynamic object. That's what that number is. And so I can use that to identify the other objects in the scene. So if I did that right, I should see when I get up to this building. Okay, it's not happening. Oh wait. Okay, no. It's definitely not working. Well, let me maybe I put the collider's not showing up in the right spot. All right. Yeah, so clearly it's not working. I guess what I could do, because I know I am, the main collider is touching things, so I could just check what those contacts are. It should just be printing off contacts constantly because it's touching the floor. No? Is my fprintf wrong? Okay, well that's good. Oh, I'm not calling the function. That's helpful. All right, so in the update here, so I want to do it, where do I want to do it? First thing, last thing, I don't think it matters. This player update function is not actually modifying the player's position. All it does is just change the velocity and let the physics engine take care of the movement. I'll just drop it up at the front. I don't think it matters. All right, so there we go. Yeah, I'm getting a bunch of printfs for zeros because I'm touching. 0 means there is no other object. That would be like the static mesh. And then I touch this building, there we go. So you can see a 5 shows up, or a 6. So that's the entity ID of the building. So each building has its own unique ID. So that one's 11. So if I were to come back now and I were to iterate over the triggers instead, it should be giving me should be empty until I get close. If I did this right, there we go. So now you can see when I get in range that it starts printing the number of the building that I would damage if I had an attack. So this will just keep track of everything that is currently in the damage area, and it'll just be that'll just be updated every frame. And it's only when I push enter that I'll call this routine. I'll create a routine that loops through all of the active contacts and applies damage to whatever that ID corresponds to. And I have some options here. So I could just pre-allocate every ID. So I could say like IDs 1 through 5, 1 through 4, off by 1, 1 through 4 would be the 4 players. And then 5 and onward would be all the buildings. And then, well, I will probably have tanks too. And so tanks would get their own range of entity IDs. But the idea would be when I'm doing the collision detection or the damage handling code here in the player, I'd get this current contact, and that contact would have that ID, and I can just say, okay, if this ID is in this range, then I know it's a building, and I can just apply damage to that building, and have that logic be handled by the building. Anyway, that I think is the plan. I want to wrap this stream up soon, so I don't think I'm gonna start on that code path. I don't know. What do you guys think? I was wanting to leave some time for questions if anybody wanted to know or want to know anything or had any questions about this, or if maybe for about 10 or 15 more minutes I could just keep moving on my implementation path as I have it planned, what we just discussed. I guess I could catch up, but there's currently questions right now. So, okay, I see there was a bit of a flame war about C++ here. C++ is just sugar. You don't need vtables. I do agree with that take. And sometimes it's nice sugar, that I will say. But there are use cases for C++. This isn't one. Yeah, ever since I started doing C code, C programming, I think that with N64 games, like I just realized how much you don't actually need all of the fancy syntax sugar for languages. Like you can get by with just function pointers, and in some ways, just having functions is way simpler. In fact, you got me on a rant. So the object-oriented programming with the way that it is built out in C++ and Java, I just think are terrible. And here's why. It's because a class becomes this inseparable ball of dependencies. So anything you pass into the constructor of a class becomes a dependency for that class. And all of the methods depend on the class. So they indirectly depend on those constructor dependencies. And the methods themselves are also dependencies of the class. So there's that circular dependency. So that means all methods in a class depend on each other. And I know maybe this is just, if people knew how to design object-oriented code correctly, then this wouldn't be a problem. But I found in object-oriented heavy code bases, what ends up happening is classes start growing and getting dependencies in either their methods or their constructor. And all of those dependencies are intertangled into that class, meaning you can't separate them out, which results in making it really hard to reuse just that class, because you pull it out and you're like, okay, I want to use this someplace else, but now it has all these dependencies because it's a big tangled ball of dependencies. And you can't just reuse the one part you want. You have to bring over the entire class. And that's not even getting into the problem with the extends keyword. When you have to extend a class and you have this like hierarchy of dependencies, and I feel like what it is programmers like cool puzzles. And object-oriented programming, and oftentimes just programming things, like you want to make the good advice is to keep things simple, but that can get boring for programmers. And so we like to make things interesting again by doing things like making up object-oriented programming. And then we get we get to start thinking about like all the cool and elegant ways of composing these things in a way that like, you know, you create this really cool solution, but really your solution could have been simpler if you just stuck to the basics. You know, you have functions, you have structures, you have function pointers, and that's all you technically need. And I get syntax sugar is nice, so I'm not going to say like it's all you ever want, but I think the way the object-oriented programming done by C++ and Java is just terrible, and I much prefer the way it's done with like something like Golang, where you just define methods on this structure, this data structure, and it can, if it can happen to implement interface, it implements the interface. And anyway, I could rant about this for a while. I am thinking I'm getting caught up on all of this. Learn C because of the Port 64 videos? Well, you're welcome. Atarg. I'm just gonna mess up everybody's names. I'm sorry, but yeah, I like C now. I've been, I don't know. I'm even slowly turning into to Linus Torvalds, but any reason I don't type def my structs, I just don't, and maybe I should, because I think it really is kind of silly to have to type struct over and over again, but I just don't. And I know it's just like I could do this right now. Like I could just do like what, a type def. Maybe this is why I don't, because I don't remember how to do this. Is that right? No, it's the type first. There. And so now I could just come here and rampage player, I could just replace that. And now my code's shorter. I could do that. I don't. I don't know why. I just, it's stupid, and I'm sure somebody could convince me. I'm not too firm on this, but it's just, I just don't. The power of C++ is that you can use it like C or like Lisp or like Java. It's up to you. Yeah, but I don't know if you want all of the features in a language. Like, have you ever used Scala? Has anybody ever used Scala? Like, it's a cool language, but I feel like they got so carried away with adding features, and like they wanted to make it like, there's some examples like look at this really simple, well, not simple, but really short code where you can see like I'm able to express this complicated thing in this one line, and I'm like, how do you debug that? How do you debug that? You have all these language features, so you can overload operators and do all of these things, and you can make it so your code maybe looks nice until you have to debug it. And now suddenly, like, it's a pain to step through, and you don't know what, if they're like operator overloading is really cool syntax sugar, and I might be convinced that it's the right thing to do for mathematical things, but I draw the line there because it's not clear that it's actually a function call, because really that's all it is operator overloading is just syntax sugar for a function call, and I'm not convinced that it actually is better to have operator overloading than not. But how long is the game jam, and how far to finish is the project? The game jam goes till December 13th, and like any project, the amount of work that has to do is kind of up to me and the team, because we could go and make this much simpler than our plans, or if we get things done if we get the basic of the game done first, then we might go and try to make it a little more advanced. And I think that's the best way to think about any project, is like, you know, how I hate okay, and maybe I'm very difficult for project managers at work, because they always ask me, how long is this going to take? And my answer is, I never give an answer, because my answer is always, well, how long do you want it to take? You know, what other priorities do we have? What else are we working on? How polished do you want it? Because all of those are factors that can change how long it takes. And so I never get a straight answer, and they probably hate me for it, but that's how I operate. I mean, I'm not getting caught up here. Filling this structs and functions for the win. Yes. As someone that gets easily overwhelmed by choice, I like the restriction C imposes. Yeah, I think I could agree that. Struct is still more expressive. Same reason. Well, I'll never use auto. Yeah, I can respect that. It's tempting to use auto though when you have like in C++ you have some really long type name that's like what would be like std unordered map, and then you have a template type, and then you want to get the iterator from that. I'm like, I'm just gonna use auto, but maybe yeah, I can respect that though. Python and assembly, liking Python and assembly, crypto guy, like yeah, that's kind of like you pick two opposite ends there, and you're like, I like this and I like that, nothing in between. No, no, I can be on board with Python. There's some things I haven't used it a whole ton. I'm cool with Python. Um, guys here, observer subscribe factory singleton. Right. Yes. Have you guys seen Enterprise FizzBuzz? That is a great example of how patterns can be taken way too far. Where you're supposed to be implementing FizzBuzz, but instead it's like this big complicated mess of patterns and factories and observers, and it's a mess. So what is going on is I am kind of wrapping up the stream. I'm just wondering if anybody has any questions that I am ranting about programming languages. So do I use a memory arena for allocation? So currently I just use the built-in memory allocator for the game, and then I deallocate. I haven't really done any sort of custom memory allocation yet. I probably won't for this game jam. I don't think I'll need to. Although, and another thing I like to do is I like to try to allocate all the memory I need in some capacity at the start, and then I don't have to do any mallocs in the game. Definitely don't want to. I want to avoid doing memory allocations once per frame. For example, like if I have a function call, you can actually allocate memory on the stack pretty easily, and I prefer to do it that way if at all possible, because it's faster. It's not only is it faster because I don't have to do the allocation and deallocation, it's also faster for the cache, because the stack is probably warm in the cache already, meaning if you allocate on the stack, you'll get much better memory access patterns and then it's really important for the N64. So I prefer to do stack allocations if at all possible, and then yeah. Auto will save you from having to type a gazillion implementation of the same function. Yeah, that's true. Auto's nice for functions. What clock was that in the background? Oh yeah, cuckoo clock. It was my in-laws went to Germany this past year and they got us a cuckoo clock, so very much like that one. Lua for me has been fun and easy to learn for custom game mods. Yeah, I actually, Lua is one of my first languages. Lua has a special place in my heart. So, how much memory does N64 give you access to? Access to all 8 gigabytes, well, 4 gigabytes for the base console, 8 gigabytes if you have the expansion pack. It just gives you, like, I can just write a pointer to direct memory. There is no you guys hear that? There's no restriction. There's no you could just be like, you know what, I'm just gonna go and start reading all of the memory from RAM. There's no operating system layer where there's like a user mode and system mode. It's all system mode. You can just have full access. So anyway, I think, oh, gigabytes. Did I say gigabytes? Yeah, I said gigabytes. Sorry. Thanks for catching that. 4 megabytes. Very big difference. Only 4 megabytes of memory on the base console, 8 if you have the expansion. Opinions on Rust? I want to learn Rust. I think Rust sounds cool, but I haven't learned it yet. So anyway, I actually do think I am going to call it here before I start rambling about other things too much. I hope this was helpful to anybody trying to get into game development for N64. So it wasn't a whole lot of coding, but we did at least discuss some collision detection stuff that hopefully was helpful. And Just one more last call out to the algorithms. My favorite algorithms, because I'm a nerd, GJK and EPA. They have terrible names because they're just named after the first initials of the authors who wrote the papers. But if you want to write your own collision detection library, I recommend you use this algorithm. You can use it in 2D and 3D. You could find existing implementations to use, and that'd be totally fine. If like that's totally cool if that's what you want to do. But if you want to kind of get into the weeds, this is a fun one to learn, and I would totally learn this one if I were you. It's really cool. So yeah, expanding. Oh wait, no, EPA is not named after the authors. I lied. GJK is. See, Gilbert, Johnson, and Kearthy. So learn these algorithms. They are legit real cool. So that's the takeaway, if there's anything else. But anyway, you guys have a good one, and take care.